Uh, I am alone and I can not use a mask. So, my apologize for this unexpected situation, just because we right now have an unexpected Zoom session with our service engineers. It needs for repairment work for our microscopes. So, and right now we are starting. Are you ready?
Yes, Captain.
I hope. So, I am Dr. Alexandr Arbuz, works in a core facility. My position is research facility coordinator, and I am head of electron microscopy lab. We have an electron microscopy facility, and it situated in C4 block. The first floor of C4 is our lab. We have an just main part of our lab here with microscope, and else one lab for sample preparation. So let's start from main facility. Our facility is situated in a clean room, and due of it, we need lab coats and shoes coats. It needs for it needs it is not my size. Yes. We have special requirement for lab coats and another so all in this lab, all who come for this lab needs for this. So the main facility consists 1, 2, 3, 4 small labs, and we have 3 main microscopes. You can see one of it. This is small scanning electron microscope. We use this device for simple cases, and we use this device for self-use too. Yes, if you have an experience, you can use this microscope for self-use. Just because a researcher should to know about your sample more than an operator or somebody else. So this is the main room of our lab, and you can see our microscopes. That big microscope is transmission microscope, and it gives ultimate magnification and resolution. Of course, when I see ultimate, I mean here, just in university, just because of course this is not this is not ultimate around the world, but here around some 100 kilometers, this is the best machine. And we have big scanning electron microscope. One moment, please. I will switch video. So this is the main scanning electron microscope. This model is one of best model around the world. Okay, just a few minutes and I explain all of your question. So just some brief information. So transmission microscope, scanning microscope. The scanning microscope shows all about surface of your sample. You can see you can see best resolution of your sample, just for example, like this one. Just for example, it could be biologic samples, it could be material science, or just for example, like this is steel substructures, or some of these samples without some limitation. It could be nanoparticles details. You can see a scale mark. This device is most of using device around all natural sciences. We use this microscope for investigation of material science samples. I mean, thin film. It could be thin film. It could be semiconductor. It could be new battery elements. It could be new solar cell elements. All of material science. It could be new materials for some constructions. Also, we can use this microscope for biology. You can see diatoms or cells or something else. This is one of best device for investigation cells in details. Of course, it should be dead cells, not alive. But you can see all of external and internal structure of these cells. Also, we can use this microscope for some engineers, for some engineering application. For example, we can study just we can study construction materials from some from building or from industry. We can investigate, for example, we can investigate the corrosion of oil pump, oil tubes. Yeah, and for example, we have an work with investigation of coke after coal burning. You can see some elements in this matter. This is a real case from Ekibastus power station. We take coal and try to see inside of this coal and find some of its thin structure. Also, we have an archaeological application on this microscope, because you can investigate some small details on archaeological artifacts. We have such experience too. This is one of I think that it's one of most using device around all of course facility, because all people, all professors, all researchers needs an electron microscopy, and all of researchers needs an analytical application of this microscope. Some words about analytical application. The electron microscope, it is not on just microscope. It is not just machine for good resolution and zoom, and zoom. The modern electron microscope, this is a serious analytical device. What kind of analytical? So we have an Egs detector. It needs for investigation of chemical compositions, dot by dot, just in situ during the observation. Also, we can analyze a structure composition of our sample. You can see some example here. It needs it called EBST techniques, and this is some like XRD. Just it's very, it have same mechanism and same output, and you can make a map with crystallographic orientation, or map with for example, map with some phases. Just for example, you have 2, 3, or 5 different phases, yeah, in your sample, and you need to recognize it. You can use this device and recognize dot by dot where is the exact chemical composition and where is exact structure. Of course, you can take this data from XRF or XRD, but the main feature of electron microscope that this data should have a big locality, and you can visually recognize what is it. Just for example, some rock or another morphological element on on your sample, and you can recognize it. Who is who? It is really great. So also we have a focused ion beam, and we can cut in situ by ion beam. Just for example, it could be used for 3D tomography. You can cut layer by layer with a huge accuracy. Or just for example, you can cut 20 nanometers, 20 nanometers, 20 nanometers, 20 nanometers, 20 nanometers, and make electron image, and for example, chemical composition map, structural map, layer by layer. This is most powerful instrument of modern material science. This is really powerful instrument, and you can cut material science sample or biological sample, it doesn't matter. Also, you can use this ion gun for cutting, for example, just you can cut your name on sample, for example. Yes. This is not serious science, but you can do it. But if we will use a serious application of ion beam, you can cut, for example, contacts for nanoelectronics elements, for example. This is really useful thing. Also, we have a secondary ion mass spectrometer here, and you can analyze not only chemical composition and structure composition, but you can analyze isotopic composition too. And this is really ultimate kit. Just I have seen a good powerful microscope with high resolution. I have seen a good microscope with FIB double column. I have seen good microscope with SIMS column, but without some of these detectors. But here we have a all-in-one, and this instruments kit opens many doors for our researchers. Also, we have some another features of this microscope, and if you're interested, I will explain two. but right now I want to say some words about our big microscope. So, who have some questions about this microscope, about scanning electron microscopy? So, okay, let's continue here. So, this microscope provides a 0.8 nanometer of resolution. This microscope provides 0.3 nanometers of resolution, but this is not main feature of this microscope. The main feature of this microscope is information. As I said before, scanning microscope shows all about surface of your sample, but transmission microscope show all about internal structure of your sample. Just for example, I will show some pictures for comparison. For example, this is nanoparticles. You can see scale mark here. This is one of easy sample for this microscope, and we can observe it without some sample prep. But you can see that these particles have some transparency here, here, and here, and you can not catch something on surface of these samples. For example, you can see here, this is nanorod of Dr. Kaikanov, and you can see also some transparency of on this sample. What kind of this information? I will show you on the next image. Here. What do you think? What is it? What should be this strange structure? I think that it takes a long time, and you cannot give me an answer. This is a this is a stainless steel. On this microscope, we can observe stainless steel sample, and our sample is transparent, and you can see all internal defects inside the sample. And it doesn't matter, it should be a nanoparticles, it should be a biologic sample, it should be some ceramic, or it should be metals. Yes, here you can see metals like an like an leaf cells on ordinary optical microscopy. And here you can see all defects inside your sample. You can see stresses inside sample, and if you have a good orientation your sample and good sample prep, you can see the single atoms inside the crystallic lattice, of course. Just for example, this is an graphene. You can see crystallic lattice, and you can see the scale bar, 2 nanometer, and you can see stresses, and the crystallic lattice here have a stress, and your feet you have a we can see something like a waves, and this sample is not some unusual for this sample is not unusual. This is ordinary sample for ordinary capabilities of this microscope, and we can observe crystallic lattice for a lot of materials. The base materials, of course, is graphene, graphene, and carbon nanostructures. This microscope is best device for investigation of carbon nanostructures, because you can see it in transparent light, and the good question. Thank you. So, of course, all of microscopes can have some influence for sample. Our big microscope have an accelerating voltage up to 100 up to 100 kilovolts, and we can see on this microscope like on accelerator, just because here in electron gun we have an accelerator of electrons with voltage 80, 100, and more kilovolts. And of course, these electrons have some interaction with samples, with matter of our sample, and it can have some influence. So, but this is true not for all sample. Some sample, some of sample could be not so good for microscope, but a lot of samples it is normal. It is not critical for internal structure. Just because 100 kilovolts it is powerful, but it is not enough for example, for processes of rebuilding of crystallic lattice or something else. But for example, if you focus electron beam and leave it on, for example, for day or 2 day, of course, it will be damage of your sample. And of course, here, if you leave electron beam for a lot of time for one small area, this area should be burned. But all of this extremely depend from nature of your sample. Just for example, biological sample and some could be polymers is not so strong. But if you can observe the metals, you can do it with big kilovolts during the long time, and your sample have no any damage. But you, as a researcher, should think about it all time. It needs for proper interpretation of your result. Just because you can take a wonderful result, but without proper interpretation, it is not so nice. So, any questions? So, okay. And in the end of this lab tour, I will speak about our own scientific activity. As you know, the core facilities, all laboratories of core facilities have a common use, and all of our professors, researchers, or could be students with our own professors, yes, can come here and use our microscope. Of course, this is not so easy, and operate of both microscope should be only with operator. But you can take your sample and come for us. So, and due of it, I think that more than 70% of all research activity in the field of natural sciences and engineering sciences have relation with this laboratory with using of electron microscopy. So, except of it, we also have some small research activity. For example, I have 2 grants of our ministry. I mean, Ministry of Science and Education. I have 2 projects about research and development of new extra radiation resistant materials for nuclear engineering. The first project about zirconium based alloy, and second project is about steel with about steel with dispersed nanoparticles of oxide of yttrium oxide. Yeah, these small particles is like a stock surface for radiation defects inside the grain, inside the crystal of metal, and all radiation defects goes to these crystals and disappear. And due of it, the material works more, works hard, and works good. This is one of relevant direction of nuclear materials, and if we will create something new, it have a big perspectives, and we can try to do it. So, and after it, I want to show sample prep room, just because electron microscopy, it is not so easy, because good results depends from a good sample prep. And if you have a wonderful sample, but you have no proper sample prep, you can see nothing. It have a big matter, you know. And the main feature of microscopy in that fact that we have no hard protocols for sample preparation. We have no hard single protocols for sample preparation, just because any sample is unique. Any sample has own peculiarities, and you can think how to prepare, how to make each sample better, and how to give ability for speaking for this sample. No, and we have additional rooms for sample preparation. I will show you these rooms. This is a small optical microscope for sample preparation, for control of sample preparation. And here we have a small facility for preparation of leaf cells. Preparation of leaf cells have a big relationship with chemistry. You can see typical chemistry facility. The main part of work we take here using special chemicals for fixation and for contrasting of sample. And after it we have an ultramicrotome. So it looks like an optical microscope, and it looks like a microtome. If somebody of you have a biological background, I don't know. But the main feature of this device is capability to make ultra thin layers. When I said ultra thin, I have mean an 30, 20, 40 nanometers. It is really thin, but we can do it. It is all about biology samples. If you have a sample, one moment, please. So, if you have a sample with a sample from something solid, like this, for example, you need additional sample preparation on special mechanical machines, and I will show you too. I will show it too. We have else one special facility here. This is facility for sample preparation for material science. If you have a solid sample, like for example, like a rocks, yeah, or this one, yeah, you can cut it before, and after it, grinding, polishing, and coating for better result. We have a special machine for cutting with extra accuracy. We can make very thin sections by this saw. And we can make such small plates. It needs for proper sample prep of metallic samples, for example. So it have a full of automatization, and this is a really nice machine. After it we can polish our sample, grind and polish our sample, and one moment please. And after it, when we have a really nice surface, like a mirror, after it we should make the structure visible. For it, we use electrolytical cells. This one for ACM, and this one for transmission microscopy. Just because for transmission microscopy you should take a very thin very thin area, something around 50 nanometers for good result. And we can take this area during the 1, 2, 3, during 4 operation. And this is not so easy, and each sample have own peculiarities, and each sample wants attention. So if you sample not conductive, you can coat it by thin film of gold, or for example platinum or palladium. Here, this is easy and fast operation. Also, you can, if your sample is really small, you can mount it in on this machine in such blocks, and grind and polish and observe after it. This is also a very nice machine, just because we can do this operation by 5 or 8 minutes. It is very fast, and it have a good quality. And also we can cover our sample by carbon film. It needs for organic sample. So it was a really fast excursion. You can see another equipment, but this equipment is not our. This equipment belongs to engineering help desk, not for our facility. So right now we will return in my main lab, and I want to answer for your question. This is our lab, and we will enter. So and right now I want to hear some questions and try to answer on it. Oh, nice question. So, no, you cannot use gases as a sample just because it have no some matters. You cannot see a gas in microscope just because it will be transparent. And if you try to see something in electron microscope, it will be dangerous because electron beam will ionize any gas, and due of it we will have a big spark and plasma, and it is not so good idea. So the electron microscopes, yes, the electron microscopes used for semiconductor industry for control of products and for research and development, because this is the main device for analysis and control. Yes, of course, we have courses about basic of electron microscopies. This course have in 1 week, and we sorry, and we have this course once per semester, or could be 2 times for season. The last course was 1 month ago. The next course, I think, could be maybe May or June. I think that in June, but it depends from our users. If we have a big the next answer for Paulina. So I think that we will discuss about it, and we will find some variants. I think that it's possible, but just it needs for discussion. Nice. Just one of small parts of our mission is educational mission too. Just because when researcher or professor go to this facility, he should know something about methods, something about some peculiarity of observation or interpretation, and this information should answer for some typical questions and should it is really good for all for both sides. Else questions?
We don't seem to have any questions, I guess. So I think that concludes our lab tour for today. Thanks again, Professor, for giving such a great tour of the laboratory. And now I think the participants know a lot more about microscopes, and we would be happy to visit the laboratory hopefully very soon.
Yeah, me too. So I will be glad to see all of you here. If you take some of your sample or takes some of your questions or takes some of your professors. So, but of course, you should use a mask.
Yeah, thank you. So the laboratory tours, just to let the participants know that we are uploading all the laboratory tours on our YouTube channel. So if you missed any questions that were asked here, you can find them on the video.
I think that's all.
Thank you. Thanks a lot.
Thank you so much.
Thank you. Bye.